Hi, everybody, and welcome to a new EBI seminar series. This semester series is going to be really important as we talk about the bioeconomy. Recently, the EBI received almost $13 million in NSF funding to develop a new center here at UC Berkeley called the IBMC, or the International Bioeconomy Macroalgae Center. The center will focus on ways to develop the use of seaweed in the global supply chain. And as the center is developed, this series will be talking with a myriad of experts involved in the creation process. Today, we're going to be kicking it off with Professor of Microbiology at UC Berkeley, John D. Coates, who is also the director of the EBI. He'll be joining us to talk about the future of the IBMC and how it will develop the seaweed supply chain. Thank you for watching and enjoy. Hi, John. Thank you for joining us today. How are you?
I'm great, Logan. Thank you for asking. How are you doing?
I'm great. Thank you for asking. Okay, so today we're going to be talking a little bit about the IBMC, and what that stands for is the International Bioeconomy Macroalgae Center. To start us off, can you tell us what macroalgae are?
Sure, yeah. Macroalgae is the scientific term used for seaweed. And these are the large aquatic photosynthetic organisms that grow in marine and freshwater environments. Uh, Seaweed plays a crucial role in their ecosystem by producing oxygen, absorbing carbon dioxide, serving as a habitat and a food source for various marine life. It's traditionally been commercialized by the food industry, especially in Asia. However, many recent scientific discoveries have highlighted the potential of seaweed as a feedstock for a broad range of diverse industries, including biofuels, pharmaceuticals, and biomaterials, due to their renewable nature and their high biomass productivity.
Okay, perfect. And can you kind of explain to us what the IBMC aims to achieve and what its significance is?
Sure. So the IBMC aims to create a global umbrella program to facilitate the scientific advancement and responsible development of the seaweed bioeconomy. It involves five programmatic areas related to basic research, scalable cultivation and harvesting, processing and conversion of seaweeds, circularity and waste management associated with seaweed processing, and socioeconomic and ecological impacts. The center really focuses on harnessing seaweed for bio-based products, renewable energy, agricultural biostimulants, and environmental benefits such as carbon sequestration and nutrient recovery. Its significance lies in promoting a circular bioeconomy, reducing reliance on fossil-based materials, and supporting global sustainability efforts.
Okay, and we've kind of brought up this term multiple times now, so can you explain to us what the bioeconomy means?
Sure, the bioeconomy is an economic principle that is reliant on sustainable biomaterials. So you can think of the use of agricultural products as a feedstock for making things like bioplastics or biofuels. Um, this obviously has got a sustainable value to it. And then the waste streams associated with those are treated using biological processing again. So essentially, a circular bioeconomy starts out with biomaterials, sustainable biomaterials, produces sustainable products, which can then have an end of life that's treated through in a sustainable biological manner.
Thank you for clarifying that. So now that the IBMC has started to develop, can you tell us what originally brought about the conception of the IBMC?
Sure. The IBMC was established in response to the increasing demand for sustainable bio-based solutions to address environmental and economic challenges. Traditionally, bio-based products, such as fuels and materials, depend on agricultural feedstocks, which are characterized as primary or secondary. Primary feedstocks are things like corn, which directly compete with the food industry, raising concerns about resource allocation. Secondary feedstocks are derived from agricultural and municipal waste streams, but these pose conversion challenges due to their high lignin content, which is very difficult to biotransform or to even chemically transform into useful materials. So additionally, the widespread distribution of secondary feedstocks makes centralized processing both logistically and financially impractical, which potentially diminishes the environmental benefits of their use. On the other hand, seaweed represents a underexplored resource. It has the capacity for rapid production scaling through the development of offshore farms. Seaweed grows very rapidly, up to 0.5 meter a day, to high biomass equivalents, equivalent to about 20 times that of terrestrial plants such as sugarcane or corn. They don't rely on artificial fertilizers or the use of fresh water. And furthermore, seaweeds are photosynthetic organisms. They use sunlight to trap up to 2 tons of atmospheric carbon dioxide per ton of seaweed biomass that's grown. Of the more than 72,000 species estimated, seaweed species estimated globally, over 200 of them, only 200 of them are commercially used, and of those, only 12 are actively farmed. And even then, with such a small fraction of seaweeds being commercialized, these have proven to be very rich in minerals, sugars, proteins, biostimulants, and nutraceuticals that can be exploited for a very broad range of applications in in a manner without competing with existing agricultural demands and allowing for the economic growth of coastal communities.
Okay, how interesting. So going back a little bit to the last question, can you build upon that and tell us how you originally got funding for the program?
Sure, yeah. So our initial funding was secured through the National Science Foundation's Global Centers program. And this is a program which was focused on the bioeconomy, and it's a partnership program with funding agencies in the UK, South Korea, Japan, Canada, and the US. And the IBMC brought together stakeholders in the seaweed bioeconomy from each of these countries, in addition to Israel, France, or French Polynesia, and Norway. Currently, the IBMC is a partnership of 8 countries, 14 scientific institutions, and 39 collaborators. Since its inception in October 2024, we've been actively expanding our partnerships and hope to include additional scientists and stakeholders from across the US, in addition to New Zealand, Ireland, and France in the near future. And in support of these efforts, we're actively pursuing additional funding through government grants, industry partnerships, and philanthropic donations.
Okay, and can you kind of explain to us what the connection between the IBMC and the EBI is?
Yeah, so the EBI hosts the IBMC, and the EBI is dedicated to the development of sustainable energy alternatives. And you can think of biofuels as being one of those primary energy alternatives. And looking at the requirement for feedstocks to produce biofuels at a globally scalable manner requires a lot of materials. So with that in mind, we started looking across the different feedstocks that will be available, recognizing seaweed as a wonderful potential for satisfying this need. And that started us thinking about developing a bioeconomy-based solution using seaweed. So the IBMC sits in the administrative center of the EBI. It takes advantage of a lot of the EBI programs, and takes advantage of our facilities as well.
Okay, perfect. Well, the future of the IBMC is looking really excited. And we thank you for this conversation and kind of clarifying what the IBMC is and everything.
Thank you very much, Logan. It's a pleasure to talk to you.
Thank you for checking out the EBI seminar series on the bioeconomy and the seaweed supply chain. If you've enjoyed this video, please feel free to like and subscribe to our channel for more content on the macroalgae bioeconomy. Be sure to follow along for future installments or check out our previous series and explore our social media, which are all linked in the description below. Thank you for watching and see you next time.